Analyzing collisions. In a system containing two objects, collisions sometimes occur. How can you analyze a collision between two objects? The details of a collision can be very complex, so you should find the motion of the objects just before and just after the collision. And that's going to be one of our keys here is the before and the after point. What conservation laws can be used to analyze such a collision? If there are not external forces, that is, the system is isolated, then momentum is conserved. So we have a law of conservation of momentum that we will use. Energy is also conserved, but the potential energy or thermal energy could decrease, remain the same, or increase. Therefore, you cannot tell whether or not kinetic energy is conserved. So the energy part is a little trickier than the momentum. We have three types of collisions. A superelastic or explosive collision occurs when kinetic energy increases. This occurs when perhaps a compressed spring is released, adding kinetic energy to the system. A collision in which kinetic energy doesn't change, it is an elastic collision. Collisions between hard elastic objects, such as those made of steel, glass, or hard plastic, are often nearly elastic. A collision in which kinetic energy decreases is called an inelastic collision. Objects made of soft, sticky material, such as clay, act in this way. When two carts collide and stick together, they lose kinetic energy. Collisions are inelastic whenever kinetic energy is converted to thermal energy. Although the kinetic energy before and after collisions can be calculated, only the change in the other forms of energy can be found. In automobile collisions, kinetic energy is transferred into other forms of energy such as heat and sound. These forms of energy are the result of bent metal, shattered glass, and cracked plastics. Unfortunately, you can't simply put the head and the heat, this should be heat, and sound back into the car and make it new again. Although you can recover the energy you put into gravitational potential energy, that is not the case for many other forms of energy. We have one example problem that I will work through for you, and then three problems for you to do on your own that are similar to this example problem. So we have an accident on a slippery road, a compact car with a mass of 575, moving at 15 meters per second, smashes into the rear of a car with a mass of 1575, moving at 5 meters per second in the same direction. What is the final velocity if the wrecked cars are locked together? So I'm going to do the conservation of momentum to help get started. So that means our momentum before the collision is equal to the momentum after the collision. And momentum is mass times velocity. And I have two cars. So car 1, car 2. And at the end, they are together. So they have a combined mass, and then they will, of course, be going the same velocity. I don't know if we really need a 1 plus 2. I think we'll just leave it as v. So I'm going to start there. 575 times 15 plus 1575 times 5. Their ending mass is their sum, and we are solving for the velocity. solve for V. And their ending velocity is 7.67 meters per second. So that is my answer to question A. Question B, how much kinetic energy was lost in the collision? Okay, I need some more space. Okay, how much kinetic energy was lost in the collision? So I'm going to calculate the amount of kinetic energy that we started with, and then the amount of kinetic energy we had at the end. So we can calculate how much we had at the end. So our kinetic energy equation is 1/2 mv squared. So I'm going to start here. There's car 1. Plus car 2. And this will give me the kinetic energy that we started with. So we had that many joules to begin with. Now we need our, okay, so I hit the wrong button on my calculator. I just noticed I had a 0.8 up there instead of 0.5. So I need to do this again. This is our beginning amount of energy. Our ending amount of energy, 1/2 mass, and it's their combined mass again, times their velocity squared. And to find the amount that was lost, I need to find the difference between those. So I'm going to subtract. Just going to do that in my calculator. So kinetic energy lost is 21,133.9 joules. Last question. What fraction of the original kinetic energy was lost? So now it's just a comparison. This amount lost divided by the amount that we started with. Thank you, calculator, for being super handy. And converting this to a percent, I have 25% of our kinetic energy was lost after the collision. So there are my 3 answers to A, B, and C. And now you have those 3 problems to do on your own that are very similar.